And yes, ma'am. We'll start in just a minute.
Perfect.
Do you want to move that camera
Oh,
to get both of you? That camera is just showing the one of you. Do you want me to come down and
Or
pivot that?
Sarah, you can walk over. That's fine.
Yeah.
I'm just
Okay.
sharing.
Okay.
Yeah, me too.
Wow, there's 18 people on so far.
All right.
20. It
Like
just
that?
keeps going up. This is awesome.
Yes.
Yeah, we got a lot of people, guys. Zooming in.
Excellent.
Yes.
That's awesome. We got lots of people.
All right. We'll get a few more people in the actual stands too. We'll see.
Got a minute.
Yeah, oh no, I'm not
Yeah.
complaining. I'm not complaining. I'm just saying maybe we'll get a few more.
Claire will be on.
Yeah, oh, I know. We'll at least have Claire. Yeah.
Oh, can you dismiss all? Dismiss all. I usually dismiss all. They're gonna keep popping up.
I just missed everyone.
Okay. We should have turned there's probably not a way to do it. I should probably just turn my email off. I don't know if you can go in and just totally, because I'm logged in as me. I don't know if you can. Don't worry about
I
it.
can try.
Hopefully I won't get any email. Just turn everything else off.
Um,
Don't mess with it if you're good. No, we'll be good.
I don't see, this is what we need to turn off.
Yeah.
This is fine. Yeah, I'll just close it.
Yep.
No
That way it
problem.
won't ding you the entire time.
Yep. There we go.
Not that we get that much email, but this will be the day where we'll be like, everybody, oh, what's going on? They just keep seeing us. I don't want to interrupt your presentation.
All right, I think we're at noon, so we might as well go ahead and get started.
Okay.
Okay. All right, well, thank you all in the audience here for coming. We'll go ahead and get started. Thank you for those of you who are on Zoom joining us. This is a fun moment and really kind of the first public presentation we have for some preliminary data on research that we've been doing for about a year now, and that we'll be continuing doing for the next year. For those of you who are joining us on Zoom, thanks for being here. If you have questions or comments when we get into the Q&A section, we will be monitoring the chat, but we prefer it. It's easier for us if you put your questions into the Q&A. You should see that on the Zoom dialogue. So if you have questions, please, and I hope you do, please put them in there. So we'll go ahead and dive in here. So you'll note the cover here, the title here of this project is called Cover Cropping with Solar Panels, the Environmental Impacts of Solar Development on Agricultural Land in South Central PA. And this idea of cover cropping with solar panels is a hint to some of the things that we're going to talk about today. We've got a number of projects that we'll be following on for today. If any of my students are here, you know I like this idea of rubrics in class. These are the stops that we'll take along the way. So starting off today, Sarah and I will be making this presentation together. We'll be introducing ourselves, and then we'll talk through, Sarah will take you through why we're doing this research, why it matters, what our questions are, what our methods are, a little bit about the sites that we're working on. And then I'll hop in to present some preliminary data and analysis that we have working on. And then I want to close with some reflections on what I think, having done this work for a year and getting ready to do it for another year, how I think maybe we should be thinking about these changes that are coming to our landscapes and thinking about a positive way forward for solar and for rural Pennsylvania and really rural places in the US. And I'm excited to say that this part of the project actually includes some art that I made with an artificial intelligence art generator, which as a nerd, I think was very cool. And I hope you do too. So with that, let's go ahead and get into our introductions. So I'll start first. If you don't know me, my name is Russ Hedberg. I'm a faculty member here at Shippensburg University in the Department of Geography and Earth Science. I've been here since 2018. Before that, I was getting my PhD at Penn State in geography. And I'm an environmental geographer. And if you're not familiar with what that means, essentially it means that I study in many different ways how humans interact with their environments. I'm particularly interested in food systems and agroecology. That's kind of my main way that I study those interactions. But I'm also very interested in theories about how humans and environments interact and what our relationships are. And I think that'll come out in the last part of the talk. And you can kind of just see there in some of those images, some of the work that I'm doing, obviously on solar and in the lab with soil. I've also bummed around the Bolivian Andes in a pickup truck studying tree line forest cover change. And I have another research project related to food technologies, which I won't go into here, but I just to hint that I do a lot of different stuff. And now, Sarah, do you want to
Sure.
pop in and introduce yourself?
Okay, yeah, so I'm Sarah Thompson. I did my undergrad here. I graduated 2021, and now I've been doing my master's degree. I'm a current master's candidate in the Geography Earth Science department. My interests include soils, solar and renewable energy, hydrology, and environmental sustainability, among a bunch of other things that would make the list too long if I continued. But in some of these pictures, you know, there's my graduation a couple years ago. The one on the right is a test that I was prepping for last summer for our first field season of this research project. And then a couple of pictures of me in the field and hiking. Okay, so just to provide a background on why we were doing this research in the first place. Solar energy capacity is 285 times greater today than it was in 2008. So if that gives you any indication of how rapidly solar is expanding, I don't know what will. But moving forward, this is a map of PA and of all of the current solar facilities that are in Pennsylvania. If you look at the map, you can see that a large majority of these are in the southern portion of the state. And that's because there's just lots of solar capability in those areas. This, however, is a map of all of the proposed solar facilities and solar sites that could happen. So as you can see, there are a lot of other states that have kind of started a little bit before Pennsylvania in establishing a lot of their solar facilities. In many maps, you can also see that it almost makes a direct border around the state. There is a reason for that. A lot of municipalities, our local government is different than that in other states. So that can make some changes in how the solar facilities can be put in place. But our guiding questions for our research: first, how does the conversion from agricultural land to our utility scale solar affect the soil health? This is looking at your soil carbon dynamics and also looking at your soil stability. Our second guiding question: does the co-location of sheep grazing with solar, so you have the sheep underneath the solar panels, how does that affect soil health in comparison to mowing? A lot of solar sites will mow the vegetation underneath their panels, but some are starting now to include different livestock, such as sheep or goats. One of the sites that we looked at was grazing sheep. And our case study sites. So like I said, we have 3 utility scale solar sites. They're roughly 150 acres each in size. So that can give you an idea of the capacity of solar energy that they're creating and harnessing. They're all of similar size and time of development. So all of these solar sites were developed around the same time and are of the same size. They have similar land use histories. So the crops that were grown on these sites are all within like similar groups of crops, and they all have similar soil series. So that makes it really important for comparison, because then we can count that out for any control that we have. So our assessment framework for the field work. First, we did active carbon. This is a really important measure that we're doing of a labile portion of carbon, which is a soil fraction that is very, very sensitive to management decisions. Because of the recent construction of these large-scale solar facilities, we need to make sure that the soil series or the soil testing that we're doing accounts for those changes that could have happened from when the solar facility was put in to when we were doing the study. So we couldn't really do long-term carbon studies. As some of you may know, carbon is sequestered over many, many years. It can take 10+ years to sequester large amounts of carbon. And because we didn't have that time, we needed to make sure that the test we were doing accounted for the limited time available for the soil to make that soil carbon. Our soil respiration, this is a great measure of our evolved CO2, which is the CO2 that comes from all of those little itty bitty microbes eating and doing their jobs in the soil. Soil compaction is our surface hardness. This is particularly important when you're looking at the structural stability of the soil. So if you have a soil that's very compacted, large times it will lead to increased surface erosion. You won't have really good nutrient intake because the soil is hard, doesn't have very big pore spaces in between the soils in order to hold on to all of that good stuff. Our wet aggregate stability, this is a rainfall measurement to see how stable our soil is under a predetermined rainfall rate. So is our soil going to slake off and wash away and take all of the nutrients with the soil with it? Or is it going to remain stable, intact, and in the site that we're looking at? And then finally, our earthworm abundance. This was our hot mustard test. It sounds really scary. We weren't harming any worms. No worms were harmed in this field study. But basically we hydrated hot mustard like that you would get from a grocery store, and we would pour it over, you see that grid that we have, the wooden grid. We would pour it over that, and then over 10 minutes, we'd count and see how many earthworms popped up. And we're like, oh gosh, this stuff doesn't make me feel good. So they come up to the surface, you grab them, you weigh them, and then you count them. So at each of our solar sites, we have 4 transects. If you look at the collection and assessment design on the right, you can see that we have different transect or different sample locations within each of the transects. So we sampled in both the open areas between panels, directly underneath the panel, and then on the drip edge of the panels. So we have 12 sample locations for each of our transects, which gives us 48 total samples within each of the solar sites. And then we also do 15 background sample collection just to make sure that we have our controls. So in total, with our 3 sites, 48 in solar, 15 in background, we have 189 total samples. So this is my time to tell you that lab work takes a really long time, and to never underestimate how long lab work will take you. You will always have things that come up, or if something doesn't work right, not only do you have to redo it, but you also have to problem solve and see, okay, what went wrong with this method? What was happening? Was it the equipment? Was it personal error? You have to go back. Being one person and doing 3 total methods of soil samples for 189 samples each takes time. It is a rite of passage as a graduate student that I am proud to wear. But yeah, it takes a lot of time, and it also just takes a lot of like concentration. So not to underestimate that if you decide to pursue any projects like this. Okay, and I'll hand it off to Russ for some of our preliminary results.
All right, thanks a lot, Sarah. And I just want to also express my gratitude to Sarah for the work that she does in the lab. Sarah's one of my graduate student advisees, and she's been really the primary labor, as well as offering intellectual contributions to this project. And I remember sort of fondly the 1.5 years that I spent in a soils lab when I was in grad school. And so, Sarah, thank you. Thank you for that. So what I want to go over here with now is some preliminary results. Now, as Sarah noted, we are still in process working through the lab results for this project. And in particular, we have some of the methods done and some of the methods just really not done. Okay, so of the things that you saw earlier, we are done with the active carbon, and I'm going to talk to you about that here. We have soil compaction data. We also have earthworm data, though I'll talk about that one in a second, because I'm not going to give you results from that one. But the soil respiration and the wet aggregate stability we're still working through, both because of the kind of issues that Sarah mentioned, time, and also error on our part with needing to redo some things. We will have those in about a month, but we can't talk about them yet, unfortunately. maybe next year's talk when we have 2 years of data, we'll get all the stuff in there. So what I can present to you here is on active carbon and soil compaction. We have data for all of our transects, for all of our points collected, and I want to talk you through this. For the earthworm data, I don't know ultimately if we'll ever be able to really say anything about it for the first year. And part of the reason for that is that without nerding out too much about the statistics, we basically have a lot of binary data. We either had no earthworms or we had one earthworm in almost every case. And that's actually statistically really hard to work with. And we're going to try. We're going to do some things. We'll see if we can come up with stuff. It might actually not be able to tell us that much. We are also going to do it again next year and find out what happens. Maybe things will go better this year. But let's talk about what we can say. Okay, so the first thing I want to talk us through is comparing what we see in the solar arrays for active carbon and for soil compaction versus the background. And the background condition here is what this land would be doing otherwise. Okay, so we sampled within the arrays, like Sarah talked about, underneath those panels and at different relationships to the panel locations. And then we also went right next to the solar arrays on the same soil on a land that's got the same land use that the land that was converted did, right? So it's a background condition. What would have been happening otherwise? Now, if you, for active carbon, when we compare the active carbon in the solar arrays compared to the background condition, I want to point out here, right, what you see is this is the mean for in the solar array versus the background. And you can see both absolute differences are fairly significant, right? So we've got about 30% difference in here. And statistically speaking, when we compare these with analysis of variance, they're all significant to very high degrees of statistical significance. And this is true regardless of panel placement, right? That we see these significant differences take place. And so we see, for reasons that likely have to do with the initial site construction, though we can't say for sure, we see some loss of carbon. Now I want to note here, right, and I was actually just having a conversation with someone about this earlier today about what the term environmental impact means. Everything that humans do impact the environment, right? So I'm not trying to suggest here that this is bad or that it's good, right? But that we see activity having an effect on the environment. And that's really what we're curious about here. What are these effects and what can we do to reduce them? What can we do to encourage ones that we like? And how can we have this help us think about building a renewable energy infrastructure? Okay, so we see these numbers change. Neither of these numbers are necessarily bad either. From an agricultural perspective, 550 parts per million of active carbon is not terrible. Okay, so if you're doing a soil health assessment for a farm, you're actually not terrible there. 700 to 800 is actually really good. Okay, so we can think about this. If we put these numbers in perspective, we don't see bad, we just see a change. Okay, now for soil compaction, we have a little bit different outcome. So for the first site, and site 1 is the site that has sheep grazing, okay, we do in fact see a significant difference in soil compaction. For the other 2 sites that where we don't have grazing, we don't see a significant difference between the background condition and within the solar arrays. Now I'll also make the caveat here, like I did with active carbon, that all of these soils are really, really compacted. Anything above about 21 kilograms per square centimeter is considered heavily compacted to the extent that plant roots can't really penetrate the soil. So these are all very compacted soils, both the background condition and within the solar arrays. So just putting those numbers in perspective, right? Yet we do see with grazing a significant difference. Okay, now for the effects relative to panel placement, things actually start to get a little interesting when we're talking about carbon. We see that, so you see, this is across all 3 sites, right? So I've combined all 3 sites. And across all three sites, you see the mean there across the top for the mean parts per million for active carbon. And you see more in the area that's below the panels than you do either on the drip edge or in the open. And those differences are statistically significant. As you can see there, those are p-values, right? So anything less than 0.05 is considered statistically significant the way we structured these tests. So we have highly significant differences. And this is also true at each site individually. Now there's some reasons why we might see this. It could be that the decrease in vegetative activity underneath the panels is impacting the way that carbon is accruing, right? So, and we'll know more when we see soil respiration data. If there's a lot more respiration activity outside in the drip edge or in the open, then that can tell us that there's more microbes processing that organic matter, right? So there's just a little bit less accruing because different ecological processes are happening. So there might be more total carbon, but it's getting eaten up by microbes. It could also be, and we have no way of assessing for this, but it could also be that there is some novel hydrology that's being introduced by the solar panels. And we do tend to see the lowest active carbon on the drip edge of the solar panels. It's not significant compared to the open areas, right? So I don't want to put too much stock in this, but it could be that we have rainfall falling on the open areas and on the drip edges, and we don't have rainfall falling underneath the panels. And so we see some carbon moving from the open areas into under the panels. That could be, we're not testing for that. So I'm just speculating because that's what these numbers invite us to do, right? And and future studies should definitely look at this in particular. For compaction, we do see that the soils below the panels are more compacted than the soils out in the open. This is, if we take all of the sites together, we see this. If we look at each site individually, we see some slightly different outcomes, although the areas below do tend to be slightly more compacted. I suspect that this has to do with the difference in hydrology because the soils aren't getting rained on, and so they just tend to be harder. And there's less root penetration in that area, so they just are a little bit harder. Again, let's note that these numbers are all still showing very high compaction, right? So, and the magnitude of differences is not as big, even if it is statistically significant. Now, the last thing that I can offer you is comparing the effects of grazing. And here again, things are interesting, and I think we might know more once we have all of our data. But for now, we can say that there is no difference in active carbon between the grazed and the ungrazed sites, and that the grazed site is significantly more compacted than the other two. And in fact, the background condition for site 1, where there's grazing, is statistically similar to the other two sites. And so it seems like sheep grazing is having an impact on compaction, not terribly surprising, knowing that grazing animals compact soil. And we have the stocking rates in these solar fields, and this is not just true for the site that we're looking at, but it's pretty typical that during the season, in order to effectively manage the vegetation, you graze between 500 and 700 head of sheep in those fields. So it's a pretty high stocking rate in order to manage that vegetation. And so you see some increased compaction on soils that are already compacted. Now, the active carbon one is kind of an interesting question, and here's where I think it's going to be interesting to see the respiration data when we get it, because other studies that have compared grazed to ungrazed and have looked at total carbon have actually found more total carbon in grazed areas as opposed to non-grazed. And so I suspect that we'll see more soil respiration with the grazed site than we will with the non-grazed sites. And there's reason to believe that, right? Because lots of studies have found that applying manure to soil tends to increase soil respiration in particular. And so we'll see how that turns out. I also want to note here too that these sites are less than 2 years old. And we are going to be repeating all of these assessments again this year. And all of these things that we're doing are highly sensitive to small changes in management. So it's entirely likely that from this year from last year to this year, we'll see changes in all of these. I'll be interested to see what directions those changes go in, especially comparing grazed to not grazed. Okay. Now for some broader consideration of how we should think about solar in rural places. We tend to, as people, and now I'm going to put my college professor academic hat on, okay, where I'm gonna get a little into that human environment theory part of the stuff that I'm interested in here. We tend to think about landscapes as binaries. They're one thing or they're another. This is an agricultural landscape. It's a farm. If solar panels get put on it, it's not a farm anymore. Okay, and so a lot of the ways in which we talk about placing solar in agricultural landscapes is that it is temporary and that it is, like we have in the title, kind of like cover cropping with solar panels. We're just taking a break here for a little while and we'll go right back into it. Based on what we're seeing right now, there are some changes that are being introduced. I don't think that they're necessarily bad changes. And in the context of other types of land uses, they're pretty benign. Industrial agriculture, conventional agriculture tends to have a bigger impact than what we saw for conversion, for instance. Warehousing, which is one of the big concerns, especially along the I-81 corridor, has definitively a much bigger impact on the landscape and on the ecosystem services than solar. But it's also a novel ecosystem. It's a novel land use and it's creating novel ecosystems. And I think that that actually opens up a great deal of possibilities for us. There's a lot of fear, I understand, in rural places about what these changes might mean, right? And if we think in that binary, if it's not a farm, then what is it, right? It's an energy landscape. It's becoming something terrible. This is mountaintop removal, right, in West Virginia. Clearly a really terrible use of the landscape. This is not what's happening in our rural places with solar. And there's an understandable fear of what might happen to a place that's familiar to you, that you love, in making land use changes. Okay, I also want to note that what we see happening is not this either. Now we're getting into the fun AI art, right? I asked DALL-E, the AI art generator, to make me a solar photovoltaic energy sacrifice zone, and this is what it made me. And I think there's a real fear, right, that as we rush to decarbonize our energy sector, that we're going to blanket the earth with solar panels. And I can understand that. If we were to blanket the earth with solar panels, we would produce about 1,000 times more energy than we need, right? So we actually don't need to do that. And we're not really trying to. What we see happening in rural places and the sites that we're working at is something different, and I think something that's much more exciting, because it's not just an energy landscape. There, Sarah showed the photo of the flowers blossoming. There's really biodiverse land cover mix that's planted underneath these solar panels that is intentionally designed to feed pollinators. And it's really beautiful. And it's providing ecosystem services. And in a lot of cases, and increasingly, we see agriculture cited, specifically animal grazing, right? Chickens in Europe and sheep in the US. So agriculture is also happening. It's more than one thing, in other words. And this invites us to, I think, dream about what these landscapes could be. And so I want to introduce a term. This is an academic-y term. Anybody who's had me in class will know I like to talk about stuff like this. A cyborg, right? And I'm using this term that was introduced by the feminist technologist Donna Haraway. The cyborg, right? It's a bundle of contradictions that meld together in the same space to create something that's wholly new. Now, I'm not suggesting that farmers start talking about their landscapes as cyborgs, or even that solar developers start talking about the cyborgs. That's my job, right? As an academic, this is a cyborg. What we have here is a new land use that is combining solar and agriculture. It's not one thing, but it's more than one thing. And when we can recognize those contradictions, energy and food production, energy and cultural ecosystem services, it opens up a lot of possibilities. So this is another image from DALL-E. This is a community solar commons with agriculture. And you see something different here, right? We don't have sheep grazing under dense solar panels. We actually have panels that are farther spaced apart, and we have crops in between. And test sites have shown that you can produce all sorts of staple crops and vegetable produce and fruit produce if you're willing to think a little bit outside the box about how we space panels out, right? We're not maximizing any one thing, but we're actually being incredibly efficient with our land use and producing more than one thing. It's contradictions, okay? Again, right, we can imagine what these landscapes might look like. And in imagining them, I think this opens up a lot of possibilities for us in thinking about the solar future that we want in these rural places. I think that it's fair to say that people who live in rural parts of Pennsylvania don't particularly want warehouses to be in their backyard. I know that I don't want a warehouse in my backyard, okay? I understand they have to be somewhere, but there's a concern. But solar offers a unique opportunity because the solar panels can be taken out or they can stay in all sorts of different arrangements, okay? And we need lots of solar in PA. By 2050, we need to be producing essentially all of our energy from carbon-free sources. And that means that rural parts of PA are going to have solar panels on them. But thinking about these landscapes as not just one thing, not just as solar, not just as agriculture, but as something different, I think allows us to imagine what we might want, okay? And I think it offers opportunities for rural landowners and for solar developers to come to the table and have a broader discussion about what we want and how we can make that work. And I hope that that's where we see this go, right? I think that that's what's exciting about solar, is that it allows us to think differently, because we don't have to just wipe out what was there and completely replace it. We can build something different. All right. I'm going to stop nerding out on you now and just say thank you, okay? And I hope that I see there's at least a couple questions in Q&A, but I'd love to take questions. So Sarah and I would both love to take questions from you all in the audience. Yeah, go ahead. The ANOVA test, it was, well, the confidence level was 95%, right? So it was, alpha was 0.05. If you're for using the statistical jargon. Yeah.
This is one related to statistics too. The person asked, there was a significant amount of excavation on site one and probably on the other two. Wouldn't that affect the results compared to the adjacent soil?
Well, that's kind of one of the, yes. And so, well, the excavation is a interesting question, and I can't comment specifically on the levels of excavation at these different sites. I mean, I know, but I can't comment on it. There's site prep that happens at all three of these. And there is some amount of grading in order to make roadways and in order to smooth out some variations in the landscape. And that's kind of one of our primary questions is, we know that this is minimal land use change compared to siting a warehouse, but there is some work that goes into conversion. So what actually happens? And some of that site prep probably is why we're seeing a loss of at least the active carbon. But like I said, if you plowed that field 3 or 4 years in a row with a moldboard plow, you'd see probably more carbon loss. So we're not talking about scraping away all of the topsoil or something like that. They would be devastating. Yeah. Karen, go ahead.
Just one comment and then one question.
Great.
One comment would be, a lot of farmers or landowners got screwed. Sorry.
No, go for it.
In the past, my gas company.
Yeah.
That would abandon their equipment.
Mm-hmm.
And just a comment is, I know that would be a big, huge concern with farmers, that the state should put some kind of law or legislation in to address bonds for these equipment that may be on site, might go obsolete, the company may disappear or whatever. So that's a concern, that what if they're left holding this?
Yeah.
you know, and, because that's a massive cost for removal. That's just a comment.
Mhm.
The second thing is, are you guys considering doing an evaluation, maybe using a shade tolerant legume or something that could go underneath that would actually help enhance the nitrogen and carbon sequestration underneath? So that you would actually could maybe enhance that soil that's caught underneath the panels. I mean, I see this as a great win-win for the
Mhm.
rural community because it brings them additional, you know, revenue.
Mhm.
But, you know, at the same time, you want to keep the soil health there
Mhm.
and, you know, look at possible other crop covers or crops to put in there that could enhance that shading area. Yeah.
Yeah, sure. So, well, I can come, I'm gonna comment on your comment, and then I'm also gonna answer your question. And Sarah, feel free to chime in here too. So in terms of, I don't know if you were able to see the panel that we had a couple of weeks ago about the model ordinance for municipalities for siting solar, but in the contracting for siting these, there is typically included in the contract a bond, a clauses in the contract that require the developer to remove the equipment, the infrastructure after the lease is done. And they are typically required, and the model ordinance that was developed for this by some folks to assist municipalities, because all this is done at the municipal level. We don't have a state ordinance, right? Municipalities, townships, all do their own, they have to make their own law and write their own contracts.
Very small rural town where there's 9% farmers. We have basically almost no zoning or municipal, so we would need assistance from the state in actually helping to protect these farmers.
Right, well, so what they've done with the model ordinance, so you do have a township at least, right? And so there is some sort of, there's some sort of legal structure where you live, right? Because even if it's not incorporated in like a borough. And so there is, this model ordinance would be something that could be served basically as a template for folks when they're drawing up legal contracts. But typically there's a bond that's required and it can be revisited in order to make sure that the stuff does get removed. Now in terms of the ground cover, the sites that we are using have incorporated a particular type of ground cover for the purposes of supporting either pollination and honeybee vitality, possibly honey production, and also grazing. So they're putting in a biodiverse mix that is like a high protein forage mix. So there probably are some legumes, but they're not specifically looking at planting the kind of cover crops that would rehabilitate soil or fix nitrogen or something like that. There are others, and you're right, absolutely right. There are other things that could be planted to enhance some of these kind of fallowing soil and soil remediation properties. But that's really kind of up to the goals of the company that's managing the site as to what they plant under there. But again, right, yeah, there's a lot of opportunity, and we don't have the opportunity to experiment with that in the work that we're doing. But I would love to see that work done. Yeah.
And just to add to, in some of the literature, there are, particularly in places out west, on smaller scale, maybe not as big as we're talking here, but there are places that do plant like agriculturally productive, heat and shade tolerant, like lettuces and things like that, when you do have a small scale. But one thing too, you have that fixation of nitrogen, all those good things going into the soil. But if you're using it for like a food production source, which I'm not sure you were saying, but if you're using it for a food production source, you also have to consider the harvesting of those crops. And the panels create like a really big kind of, can't use heavy machinery for that because you have to go under the panels. So then you're relying on like human labor, which is also an incurred cost of doing something like that. So not only do you have the cost of doing the solar and you're getting energy from that, but you have the incurred cost of the labor as opposed to the heavy machinery that you could use in traditional ag to harvest those. So.
Yeah, I envision manual crops.
Mhm.
Strawberries.
Mhm.
Yeah.
Yeah, strawberries would be interesting between the rows. Yeah. I see Sean, and then I saw Sean's hand first, Claire, so I'm gonna go to Sean and then we'll go to, oh, we have some online too.
Comments about the policy issue and the support for municipalities. Russ, I came in a little late, so I don't know if you mentioned this, but Russ and I are going to be working together on a grant that's funded by the Center. Because the legislature is very interested in this new land use and an understanding how it affects rural communities and rural municipalities. And one of the things that we're specifically looking at in that grant is kind of looking at Pennsylvania and what Pennsylvania state policies are, what support they provide to municipalities and planning compared to some other states like New York and North Carolina that have a much more mature solar industry.
Yeah, I just don't want to see the burden of the cost of hiring lawyers and stuff on these landowners.
Yeah.
So that they have a resource to go to that knows if they're gonna get their cover,
Yeah. And the parallel that you made to the gas industry is really kind of what sparks the interest and concern from the state legislature. So we're not there yet, right? Like we don't have those structures in place yet, but we're going to be working on a study and developing a report that will go directly to the state legislatures to help them navigate, what might work best.
So along those lines, someone in the chat mentioned that there are 2 solar decommissioning bills in the Pennsylvania Senate and House, with Senate Bill 211 and House Bill 925. So at least from the decommissioning side, they wanted to say that. And then somebody else asked the question, have there been any studies on the impact to neighboring property values for single family housing?
Not that I'm aware of. Sarah, are you aware? Yeah, I mean, that's a really good question. I don't think that I can stress enough that this is a very wide open field. As Sarah noted, solar capacity has expanded astronomically in the last 15 years. And so there are a lot of things that we just don't know. And I think that I view that as an opportunity to learn things and not as like be scared. I tend to think that based on my experience with in other areas, that there's not a lot of reason to be concerned that solar being sited is going to decrease property values on neighboring properties. Though I completely understand the concern. And just like we've seen with wind, that there's a lot of pushback against siting wind turbines, and then we find that ultimately it doesn't actually affect property values or tourism dollars in the way that people are concerned about. And look, you're allowed to not want it, like you're allowed to not like it. I'm not going to tell you what to think, but I don't think we have a lot of reason to be concerned yet. Although those studies should be done. That's a great question. Yeah, Sean.
So I was going to just comment on that topic. So on the Eastern Shore of Virginia, Dominion Energy has rapidly exploded the number of solar farms there. And where they encroach upon residential developments, they have a vegetative buffer setback requirement.
Mhm.
So there is there's a strip of land that is established, but down there, because that energy is sold into the grid and it lowers the local cost into the transmission lines, it actually is a little bit more appealing for local development. Energy costs are reduced. My question was to move on. So Carlisle High School has had for a number of years a solar panel array.
Yeah.
And they've had it raised option. I don't know what the current status is, but I was just wondering if you thought of sort of sampling a site that has had at least intermittent grazing on it to see a more advanced array, to be able to use that as sort of a comparative site. The other thought that I had, or the other question, especially to me, the bigger issue here is not just the carbon capture, but also the sort of soil compaction, especially in our region, especially in the western side of the valley, where this array is located on the sort of shale bedrock rather than limestone. My question is, are those animals provided full access all the time to the same spaces, or are they rotated through the solar array in such a way that there's, you know, yes, they have the grazing potential, but are they managed in a way that they're not always standing on the same ground,
Yeah.
right? And
Yeah.
causing an impact.
Yeah,
So
yeah.
that's the integration.
Yeah, and so they are rotated. To clarify, right, like there is a co-location and a benefit, like the farmers that are grazing livestock in these sites they're farmers, they're active, they're keeping these flocks of sheep, and they're benefiting economically from keeping those herds. And also culturally, depending on, you know, what their background is. From the developer's perspective, they contract with the sheep grazer to manage the vegetation underneath so that it can be low enough to allow for maintenance for the panels. And so that's why the stocking rates are what they are, and they do rotate them through in order to keep the vegetation evenly cared for. So they'll typically put up the kind of netting fences to keep them in kind of one area. They'll graze. When the vegetation gets lower, they'll move them over to the next one and around, and they kind of make a cycle around. So they're not, it's not quite the same as like progressively managed rotational grazing because they're not moving them that frequently, but they are regularly moving them. In the month or so that we were out there, the sheep were very frequently. I think we saw them probably in like several different places throughout the kind of month and a half that we were going back and forth. They were pretty actively being moved. Yeah. Do we have another question? Yeah.
Are there currently examples in the United States or internationally of community scale solar, whether co-located with food production or just on its own? Wondering in terms of conceptualizing what this may look like.
Oh yeah, there are examples of community solar, both in the US and internationally. Not in Pennsylvania right now because we don't have a legal structure to support it yet. But that doesn't mean that we won't in the future. In fact, I believe that there's been bills proposed many years in the legislature that have never come to a vote. And there's kind of been like, for whatever reason, I'm not gonna get political here, but they've not left committee. But yes, there are, and where that's available, right, that really opens up a lot more possibilities for communities having a lot larger say in why solar is sited and how and what other land uses happen there. There are also examples, the ones that I've read about are in Europe, where these are basically research sites where they've tested spacing the panels very far apart so that you can actually drive a tractor in between to harvest corn or wheat or something like that. And what those studies have found is that acre per acre, you're not maximizing the yield of the crop, you're not maximizing energy production, but you're actually, if all agricultural land was combining solar with crops, that you would actually more efficiently produce energy and crops than you would if you just like segregated them. So it's actually pretty interesting, and it offers a lot of opportunities, I think, for communities to benefit greatly from community solar. I really hope that bill comes out in PA soon, because I would love to see it.
I also want to add to that too. Sometimes these sites, a lot of the time, at least in Pennsylvania, these sites aren't being put up on agriculturally productive or super fertile soil. So that's also the flip side of it, is if you have a land use that isn't as productive as it could be, and now you're putting something on it that can be more productive than what was there previously, that's kind of like a win-win sort of thing, because the soils aren't super fertile or productive to support the crop that you would love to put on there and love to harvest. So instead you have like a new industry coming in and utilizing that land better than it could be had it just been left the way it was. So there's also opportunity that way.
Yeah, and to be clear, right, the lease payments are generally paying farmers in southern Pennsylvania more than they're making from cropping or from running dairy, which is a lot of what we see in southern Pennsylvania. And the benefit of solar is that to Karen's point, if it does get removed, I am very intrigued to see what happens to the soils in 30 years with the types of land uses and siting that we're seeing. I suspect that we will see land that was not super productive be, I don't want to say where it will go, but certainly more productive. It's not going to be exactly the same as planting hairy vetch for 30 years, but it's going to be more productive. And so it opens up new possibilities for 30 years from now, what that land becomes. Instead of if it becomes McMansions or a warehouse, it's going to be that forever, basically, until those places burn down or get torn down, right? So, it's I think, again, like a great possibility.
And one thing too, they're very, like, being out there in the sites, they're very quiet, you know, compared to some of the other industrial things that could be going on. Solar is, dare I say, a more peaceful industry to have in your backyard, because it's harnessing energy that's already there, that's already coming down every day, and it's relatively quiet. Even when you have panels that follow the sun instead of being fixed panels, they're very quiet. You know, every 15-30 minutes you hear these little clinkings, and then they move a little bit and you're like, oh, that was it. So it's really not as, I mean, they can look intimidating from afar, but when you're there and like in the thick of it, they're very quiet. So
Yeah, for sure. Yeah, go ahead.
Solar panels, generally these lands prior to having solar panels generally have a constant stream of sunlight coming on them. With solar panels, I assume that there's kind of this one spot that's going to be blocking the ground with sunlight. How will that have an impact on the soil? Will it be an impact?
Yeah, so that's a good question. And this is not true of some sites that were older, but it's a pretty standard practice now that these panels articulate. And so what we see at the sites that we're working with, they all do, right? So they track with the sun. And so really the only part of the ground that's getting no direct sunlight is the part that's really directly underneath the panels. And you do tend to see a little bit less vegetation there for obvious reasons, right? There's no direct rainfall there, and there is a little less sunlight. But the areas from what, if you recall, let me cycle back really quickly to our sampling design, that drip edge and the open, right, that you see, the vegetation on those areas looks just like you would imagine it to be if there were no solar panels there. I think that if you were really permanently depriving significant parts of the landscape from direct sunlight, you would see some ecological changes. But that's not, in fact, what we're actually seeing happen, at least in the sites that we're working at. And I think for most sites going forward, that's not, we shouldn't expect that to be the case.
Couple more questions.
Yeah.
Okay, was there any level of solar panel transparency at the location study? Currently, transparent solar panels are not efficient enough to consider in sites like those studied, but do you know of any work being done to develop semi-transparent panels that would be efficient enough to consider?
No and yes. So no, the panels that we were working with are not transparent. Yes, there absolutely is work that's being done at places like the National Renewable Energy Laboratory to develop transparent solar panels, specifically with the idea that you can then grow crops directly underneath them. And I don't personally know of any sites that aren't test sites where these have been deployed, but that's an active area of research and development in the solar industry. Yeah.
And do you have any idea of how far away a grid scale solar, I just lost it, a grid scale solar farm can be from the power grid to be efficient?
That's a good question. And they have to be relatively close to a transfer station with high capacity lines in order for it to be efficient. And the main reason for that is I've got two answers. One, they can be very far away, but it requires building more infrastructure to make it efficient. So typically what we want is to have them closer to those relay stations and high capacity lines so that we have less infrastructure to build to get the power efficiently there. If you're willing to, for instance, put a big site out there and then build the infrastructure along with it to get the power to where you need to go, they can be far away. And as long as you have relay stations in between, you don't lose a tremendous amount of efficiency any more than you do with any other type of energy generation. It's the cost is the real issue. So if we invest in infrastructure, it as a public, as like a society, a country, right? We have a lot more opportunities than maybe we do right now. Yeah. Any other questions? Yeah.
How do you see solar panels affecting like wildlife around like these farms? Like I grew up on a farm and we have 1,200 acres. And I know like once we plant like our soybean and we have our hay and corn up and everything, once we put it all down, we like to go like hunting for deer, turkey, and stuff. How would you see an effects of wildlife in these areas? Will they be moving out and like where will they be moving to?
Well, so I don't think, the main thing that as I see it, and I'm speculating a little bit here because I haven't seen any research on this, but this is an interesting question. The main thing that would impact wildlife from the solar arrays is that they're typically fenced. And so, but not being fenced, man, a deer or a turkey would have a really good time underneath those solar panels. And it would complicate hunting a little bit, but I don't see it as displacing, except for the fencing, right? And if you're willing to be if a landowner and a developer can develop different arrangements, then I don't see it necessarily being a problem. Yeah, go ahead.
So like as for, because I know like one of our biggest problems is groundhogs, because they dig holes and they eat up literally everything.
Yeah.
Whether it's like black or what.
Mm-hmm.
But what kind of like protection are you going to put like in place to prevent like these from happening? Because I know like a lot of farmers around my area are very old school and they don't like to see people on their property as like much.
Mm-hmm.
They see like truck pulling in or vans pulling in and like fix equipment when they're trying to just have their property like to themselves. How often would they have to like come out and like how long will it take for them to maintain and like if have to fix these problems?
Yeah, so good question. In the arrays that we're working in and it is kind of standard, most of the electrical is not actually buried. And so groundhogs chewing on wires is not a significant problem. Goats chewing on wires is more of a problem if you're going to graze goats, which is why we don't see a lot of goats being grazed, especially in the US. They also jump on the panels, which is not great. But when we were out at the sites, we were usually the only ones there. Except unless there was mowing, and then there was a mowing crew there that was like 2 people with big lawnmowers that were mowing. Occasionally, maintenance is typically once the places are set up, there are crews that will come through, like 1 person every once in a while to kind of make sure that nothing's broken, but it's not that significant. So in terms of, this isn't like a regularly staffed site where there's always someone on site. They typically are kind of left alone, and then there's kind of periodic someone coming by to check in on them, but it doesn't, I mean, we were the most invasive thing that was there in terms of people when we were doing our sampling. Yeah, it's a good question. Oh, we got one more follow-up, Karen, and then we'll get
We
you.
have a hand raised and we got a comment.
Okay, all right, go for it.
So as like you were saying before, like spacing out the solar panels so that you might be able to do some work in between. How do you know like how deep you are putting these power lines between each panel? I know it can be great.
Yeah.
Soil.
Yeah. So right. And so most of the wiring is above ground. They typically don't want you going deeper than like a foot or 18 inches. But I think that's mostly because they're concerned about you destabilizing the soil around the pylons where they're placed. So there would probably be some changes in practices that would be required if you were going to crop in between. as compared to if there were no solar panels at all. Yeah.
Okay.
Let's get Ken real quick and then we'll go. Do you have a comment?
I have a question from a person who has their hand raised. I have a comment in the comments.
All right, let's go here and then we'll go to Karen.
All
Okay.
right, this person is Roy Livergood. We're allowing him to talk.
Okay.
Roy? You know?
See.
Maybe it was an accidental. Yeah.
Yeah, I think that was accidental, sorry.
Okay, all right, great.
All right.
Okay, all right, then do you want to go with Karen? And then
Sure.
her comment?
Karen.
So out of curiosity, the soil that you tested was highly compacted, and it looked like it was grassland or hay or.
It's planted and it's got essentially a grassy ground
So-
cover, yeah.
So I don't know if they were just using conventional fertilizer and maybe that's why it was so compacted. Or I don't know, but maybe to do another study on fertile land that is less compacted, to
Mhm.
actually see if there's even more differences.
Mm-hmm.
I would think, because, you know, you want to see, you got a piece of land here that's not quite that healthy, or maybe seeing the differences on land that is currently healthy.
Mm-hmm. Yeah, I mean, that would be great. I'd be interested to see that. A lot of states have regulations that kind of that seek to prevent solar from being sited on prime agricultural land. And so those are harder to do. But it would be interesting to know. Yeah.
So this may or may not tie in with that because I'm not sure I understand it completely, but it says not a question, a comment. Rutgers University is completing a study to determine the viability of differing crops associated with the solar fields. They recently gave a presentation at the National Planning Conference held in Philadelphia. They are doing a research project in coordination with the New Jersey Farm Bureau with results to be completed in late 2024.
Okay,
And I have
great.
one more question. Are there any surveys currently that have been done on farmer landowner perceptions of this type of solar?
Not that I am aware of, though I would be interested in doing that work. And we're going to get into that a little bit actually in the work that we're doing this summer for the Center for Rural Pennsylvania, a little bit. I think it'd be nice to know more about that. I also think it'd be really interesting, and we also don't have, at least in the research record, we don't really know what solar developers think about the land either. I mean, we know that, anecdotally, I can say that the people that I've interacted with have been great, but I think it'd be nice to know more broadly how all of the parties involved actually think about land and landscapes and land preservation and that sort of thing. That would be good to know. Yeah. All right. Well, we're at 12:01. So
101.
101. That's right. All right. 12:01. We've been going since.
In a few days.
Yeah. So thanks everybody for being here. Thanks those on Zoom. This will be on our the Clues YouTube channel in just a couple of days. If you didn't get to see it or you want to watch it again because you had so much fun, share it with your friends. And thanks for being here. Enjoy the sunshine.
Yes.